Hello, everybody. My name is Eva Howe, and I work for a company called This Dot. We are here today for our Angular Meetup online. Our sponsor is This Dot Labs. This Dot Labs is a tech consultancy. We do all things front end and JavaScript. So if you need some technical expertise, please don't hesitate to give us a call, or look at our website. Our website is this.labs.com, and we would love to hear from you. A little bit of announcements before we start. We do these framework-specific events once a month. So next week is React Online, and the following is Vue Online on December 19th. We have two awesome speakers today, Ryan and Kara. And the schedule, Ryan will go first, and then Kara will go next. And there we go. And then just to give you a little bit of an idea for the participants about how all this is going to work, the speaker will present, and then I would encourage you guys to ask questions in the chat, and then the speaker will answer the questions at the end of the chat. I think that's it. Ryan, if you want to get started, that would be lovely.
Sure. Let me share my screen and make sure I can get set up properly. Okay, so you can see this, hopefully.
Yep, we can.
All right, so yeah, I'll get started. My name is Ryan Chenkie, and I am going to talk today about some stuff with regards to backend primarily. So presumably most of us are Angular developers here, but also presumably a lot of us might have to deal with the backend as well if we're full stack developers. And I've come to like this framework called Nest. Maybe you've heard of it, maybe you haven't, but NestJS is sort of a new framework. It's been around for a couple of years now. And it's really, really nice, especially if you're an Angular developer, because it takes some of the concepts that we know and love from Angular, and it kind of exposes those same kinds of concepts for a backend framework. So what this means is you can sort of have the best of both worlds on the front end and the back end. And I've started to think about it kind of like a way to kind of just take Angular and extend it to the back end. So it has a lot of nice features. I'll show you some of those, has a lot of nice capabilities, and we'll go through some of that and overall just kind of see how we can benefit from it. So once again, my name's Ryan. A couple things about me. I'm a GDE. I do stuff with the GDE program with Google for web technologies and for Angular specifically. For my work, I'm a JavaScript consultant, I guess I call myself. You know, I build full stack applications generally for different businesses. I do some consulting where I'm sort of embedded in different dev teams and help them out with Angular stuff mostly. But I do a lot of Angular, a lot of React, Node for the backend primarily, and I do a lot of GraphQL stuff as well. If you want to follow me on Twitter, that's my handle there, at Ryan Chenkie on Twitter. So question that I like to ask people when I learn that they're full stack developers is how do you choose your backend? And, you know, there's a few different ways to look at this. A lot of people sort of come to know a certain language or framework early on, and then they tend to want to stick to that. Others like to dabble and figure out how you know, different languages work and sort of have maybe a repertoire of languages and frameworks they can choose from. But when it comes to choosing a backend, oftentimes it's like a decision that's made sort of disjointedly maybe from our front end choices. So you might have something like React with like a .NET backend, or Angular with a PHP backend or something like that. And oftentimes those arrangements, I think just we arrive at them through, I don't know, sort of just circumstance. We don't really put a lot of thought perhaps into how we're arranging those two different pieces. And I think there might be a bit of a better way. The full stack developer, as it were, can sometimes be thought of as this creature. One side of the full stack developer is very detailed, really, really in depth. The other side, not so much, right? So this is, I don't know, this might describe a lot of us. It certainly describes me to some extent. Is like I consider myself like decent at some elements of like a front end programming world, but maybe not so decent at some elements of the back end. But I think there's a way to start to make ourselves holistically as full stack developers a little bit more well-rounded. So that's the question. How can we be better full stack developers? And I think that Nest, especially because most of us here are Angular developers, Nest can really help us out to be better full stack developers. So let's take a look at some of the capabilities that Angular has, and then maybe take a look at what typical backends don't really provide out of the box. So with Angular, we get things like modules, right? Nice way to modularize pieces of our application. Turn certain features into modules, pass those around easily, publish libraries as modules, ways that we can package things up and distribute things really well with Angular. We got the nice component model that we know of, the dependency injection model, a lot of people really like, which I believe Kara is going to talk about next. Services, routing, all of these concepts, these opinionated concepts that Angular puts a lot of effort into and is very opinionated about, make for a good developer experience for us on the other side. Now, these kinds of concepts, we might have some analogies to them on the back end, but typically we don't really get those things out of the box so much. You know, we can go invent various, like, I don't know, abstractions to achieve some of these things, but they're not really given to us out of the box so much. And so that's where Nest comes in. Nest is heavily, heavily influenced by Angular. It's kind of like considered, I think, by most people, Angular for the backend, excuse me, Angular for the backend. And what it gives us is things like modules. It gives us things like controllers, which can kind of be thought of as analogous to components. We get the same kind of dependency injection. We get services and routing. All of these things that we know from Angular, they port over to the backend, to NestJS very nicely. So what this means, I think, is that we get some really nice features like this opinionated sort of approach that Angular's got, this prescriptive and guided approach. We get this on the back end. The text-specific things that we get that I really like about Nest is we get TypeScript by default, right? So when you're approaching an Angular project these days, chances are pretty high that you're using TypeScript with it. And I think, you know, at least in my experience, I probably wouldn't have gone towards TypeScript so much if Angular didn't force it upon me, as it were, back when Angular 2 came out. So, and I think that's probably the case for a lot of people, is like they may not have been so interested in learning TypeScript, but because that prescriptive sort of opinionated decision was made by Angular that we should be using TypeScript when we're creating Angular applications, that we kind of had to learn it, right? And I think that the fact that we now know TypeScript on the front end, we probably by default want to use it on the back end too. At least that's what I find myself wanting to do. It turns out that getting TypeScript wired up for a Node.js project for the backend isn't, I mean, there's many options you can go through to do it. It's not terribly complex, but it's not super fun to set up a TypeScript project for Node. But with Nest, we get that out of the box. It just has TypeScript by default. We get to use it as we would in an Angular project. We get a nice CLI like we do with, like we have with Angular, and just basically a standard way of doing everything, right? We get a nice, clean, kind of opinionated API that we use. So again, Nest carries over these general and technical things from Angular, the things that we like, and it makes them available for us to use on the back end. So another thing that's really nice about Nest is that it kind of anticipates these things that we might need to do in a backend environment. So things like needing to delay the start of an application to wait for something to happen, like maybe a database connection needs to be made or something like that. It's going to give us tools to sort of delay the bootstrap cycle until that happens, so that we kind of have a, you know, this nice way of wiring up our applications. We don't have to worry so much about handling those things on our own. Nest anticipates something like that, many other things as well, as we'll come to see. So what are some of those other common server needs? Again, delaying app start. It's got this concept of async providers. Middlewares. If you're not super familiar with middlewares, you can kind of think of them a little bit like little pieces of software, as it were, that are sitting in between where your request comes in and where it ends up. And those middlewares might do certain things. They might check like authentication status. So like maybe it's going to check your authorization token in your header. It might do other tasks or whatever, and it'll make a determination as to whether or not the request should be able to pass through. So Nest gives us a really nice middleware layer. Communicating with databases, object relational mappers, all this sort of stuff. Nest really anticipates this. So it covers, like, I don't know, probably 90% of the things you would need to do with a backend right out of the box. Okay, so that's a lot on the sort of philosophy of Nest, I guess. Let's see what we can do with this. Let me just bump out of here. We're gonna do a little bit of a demo. And maybe what I'll do, I'll put this over here for now. So what I think we'll do is see how we would wire up a new Nest project, and we can start to see how it relates, I suppose, or the inspiration that it draws from Angular. We can start to see that in various spots. So if this is not super visible to anyone, maybe just chime in and I can zoom in more or whatever. I don't know what's happening there. Okay. So let's create a new Nest project. We've got, I've got this installed already. Let's see. Yeah, there it is. So if you wanted to install the Nest CLI yourself, it's an npm install. You would do globally, and it's at NestJS /CLI. So that would be your command to install it globally. I won't do that right now because I've already got it. And we can just create a new project. So we would do nest new. Let's do Angular Online Meetup. Well, that's what our project name will be. So we'll new up a project with Nest. And you see something like you would see with the Angular CLI, right? You see files being created. It asks you which package manager you want. Let's use npm. And now it's going to go through and install everything for us. So that'll just take a minute. And because we got a little coffee emoji, I'm going to take a sip of my coffee. Should just be a couple more seconds. Usually it's not too bad. It does take a super long time. I do have a backup plan, but let's just give it a minute. There we go. Okay, so successfully created our project. So that creates like a file directory structure for us, puts all the files in there, does npm install, all of that. So our project is ready to go. Pretty simple to get set up. So let's cd into it, cd Angular Online Meetup. And we can open that in our code editor. And what I'll do, hopefully this is visible. There, I can make it a bit bigger. Okay. All right, so the first thing that we'll look at maybe is let's jump into the source directory. And it's gonna look a lot like you would expect an Angular project to look like. You've got things that are like modules, and you've got something called a controller. Again, that's analogous to a component in Angular land. You've got this structure that sort of looks like Angular. And if we pop into the module.ts, this root module for the application, if I didn't know any better, I would think that I was looking at an Angular module, right? This looks like Angular code to me. We've got decorators. It's not ng module in this case, but we've got something that looks like an ng module. Into our controllers file, we've got something that, you know, it's got a class. It looks sort of like Angular. And that's all by design. Again, this is all because we want something that is going to operate and feel like Angular. So let's fire this up. What we get with the, let me just clear this out. What we get with a new project, if we go into our package JSON file, we've got this, where is it? Start dev command. So we can run npm run start dev. And as you can see, it's gonna do a nest start and watch. And so that is going to wire up the project. It's going to make our routes available, and it's going to watch for changes so that when we're developing, it's just going to reload automatically. Okay, so this is going, if we look into our controller file here, we've got this one method called getHello, and let's test that out. So all that we've got to do is make a get request to 3000, and then we've got hello world. So make this a bit more visible. Hopefully that's okay. So what's happening here? So the getHello method is decorated by this getDecorator. And this getDecorator coming in from NestJS Common is saying, let's have a method that is going to return something, and let's make it available at a specific route. And because we don't have any further details set up here, this is just by nature going to be made available at the / route, right? It's just going to be available there. If we wanted to say, let's have a route called ping, maybe. If we do get ping, now, if we go to that bare route, we don't have anything. We can't get anything there. But if we go to ping, now we've got it. Hello world. So that's how you would do a simple GET request. It's pretty easy to get one set up. So, what might you do with this? You might return like a list of objects, right? So ID1, name, whatever. This is something that you might do from any given route. And this would ultimately probably come from a database, right? That's kind of a common pattern. What about if we wanted to do a post request? Well, we could do a post. We would just call for the post decorator, comes in from the same spot. We would decorate this and say, I don't know, post ping, maybe let's call it that. And then the method name here doesn't really matter. Like you can call it whatever you want. You just have to give it the proper return type. So return from post, something like that. And now you just come over here. This looks like it's in the way. I'm just going to move that. Now, when you do a post request, when you go to post ping, we have got our message. So that's good. And then, the same thing goes for the other HTTP verbs that you might know, like patch and put, delete, all of those. You can get those decorators as well. And then you can get your stuff coming in. One thing that you might do with a post request, so common pattern, let's think about this. You might have something where you've got like an ID. So if you want to get to a specific resource, you might have an ID like that. And that's going to be a variable, right? You want this to be something that is determined by the client making the request. Well, what you can do is you can say you want to decorate with a param decorator. Param comes from the same spot, NestJS Common. And in that param decorator, you can essentially just say, you can give yourself like the name of what you want, ID. Or actually, I think it's like this. Yeah, so param, and then you say ID, that's going to be maybe a string or whatever. And so let's return the ID is ID. So let's do that. Post ping /2. Oh, coming in as object. Let me just log. I forget what it is exactly, how it comes in. Just want to see what it gives us. Oh yeah, so ID like that. So you would do, I think what Nest does quite often is like it'll say you should key things like this as like a DTO, a data transfer object. So you would call this maybe post ping DTO, something like that. And let's just type this as any right now. And you might do post ping DTO dot ID. There you go. ID is 2. ID is 3, etc. So you would take your, if you're needing to query your database based on like a specific ID that you might pass into it, you could do something like that. Okay, so that's cool. We got get and post requests. Pretty simple when it comes down to it. What if we wanted to start working with some of the features, I guess, of Nest, right? If we wanted to maybe do something like create a module. We've got this main like app module, but we might want to create a feature module. Much like you would do with Angular, you could do nest generate, so G for generate, and we want a module, and let's call it users. And we'll see how this all wires up here. So it's going to run just like the Angular CLI would run, and creates a users directory for us, and we got a users module. Then you might want a users controller, because you can, again, think of controllers to be kind of like components. And in Angular, you would create like a module, a feature module, and then you would have components that you would pull into it and then use that module to be your feature module. It's kind of the same here. So we can do nest G for generate, a controller, and we'll call that users for now. And watch what happens here. Kind of like the Angular CLI, it's going to just automatically bring the stuff in for us, right? So users controller gets listed as a controller. And what we've got in this controller is it's using this key users here, which means anything that we set up for a route is going to be made available at /users by default. So for example, we could do get, and let's have a method get users. Just return any for now. I'll fix that up in a sec, but returns, I don't know, ID1 name John Doe, something like that. Okay, so if we go to /users and we do a get request, there's our user. So we got that. That's great. What if we wanted to start doing something a little bit more fancy? Maybe like we want to reach out with an HTTP request to get data from somewhere else. Nest has us covered for that too. What it gives us is a layer, kind of an HTTP client, sort of like you would have with Angular. But in this case, it wraps Axios. You might be familiar with Axios, which is quite a popular promise-based, I think, HTTP request library, really popular with React anyway. Nest gives us something like that. So we can get that if we hop over here, and we need an import in this case. We need to import the HTTP module. HTTP module is what it's called. It comes from NestJS common imports. Oopsie. It's in our imports there. Okay, so we've got that. Now that means we can use the HTTP service. So let's come over here, and we'll need a constructor because much like Angular, if we want to do dependency injection, we can just list it in our constructor here. So we might want a private HTTP service, and that's going to be coming in for, oops, I got server. HTTP service that comes from NestJS common. Okay, so now we've got an HTTP service. We can use this to make HTTP requests. And so one of the cool things that Nest gives here is if you type into your methods with a particular type, in this case, you would do observable. It's going to return an observable. And then it's going to return Axios request in there. It's going to be, or Axios response, I think. Let me just double check. Yeah, Axios response. And I think you do any in there. So what will happen is this is going to help us to unwrap the observables that are going to come from the request that we make. So let's see what that means. We would simply just return a HTTP service like a GET request. So that's going to be an observable. But because we're type hinting this here, it's going to take care of the legwork of sort of unwrapping it and giving us back just the data that we want from it. It's going to subscribe to it and give us back the data we want. So let's do this. We'll make a GET request to api.github.com/users. So ordinarily that would be all we would need to do, but what you'll see here, if we run this, we're going to get, and if I go back over to here, we'll get this like circular JSON structure issue. And that's because Axios gives back data from a call on a data key. So if we are working with observables in Angular, it's much the same here. We would just need to map over it. And I don't think my editor is pulling in map properly, so I'll have to do it manually. So map comes from rxjs/operators. Okay, so map, we take our response and we say, okay, give us back the data that's on that response. So we'd say, take our response and give us back data. Okay, so this should, in theory, now give us the list of GitHub users. And there we go. So we've got data, we've got a request going to our own server that we're making, and then we've got our server making a request to GitHub server, bringing it all back. A really clean and simple body of this method will get us our data, and we can just return it as such. So that's like really kind of, I guess, a high level view of what Nest is capable of. It's capable of so much more. It gives us really a way to basically do Angular on the back end, like I've been saying. It gives us things like other things we see in Angular, like pipes. It gives us, like, I'll actually pull up my browser here. You just see some of the things that it's going to talk about, things like pipes, guards, interceptors, all of these concepts from Angular that we know and probably love. They're available to us with Nest. And so it's really nice because you're not struggling with this like context switching back and forth when you're working on your server and your client at the same time. That's something that certainly for me that I kind of have had as a pain point is like if I've worked on a PHP server or something, please don't laugh at me. Yes, I've worked on PHP service. The PHP stuff, when I have to switch between Angular and that, it kind of gets a little bit hard to do that context switching, right? So it's very nice to be able to just do one thing. So how do you gradually adopt Nest? Some people might ask. There's a couple ways. If you've got an Express application already, then you're sort of in a good spot because you can start to use this thing that Nest offers called the HTTP adapter. And it's kind of a way to delegate to your new routes or your old routes, that sort of thing. You can do that, or you can extract business logic that you might have in your Node application, and then just make that available through an abstraction to your new endpoints that you're building for Nest. If you're built on something else like .NET or PHP or whatever, that is kind of a different ballgame altogether. You kind of just have to start to do a migration, however you might find best to do that, whether it's a slow migration or like a big bang migration. There's lots of cool companies using Nest. I don't know too many of these logos personally. A couple are, obvious, like Adidas, for example. But apparently, there's many more too. Like this is just a really limited set of companies. There is this GitHub issue here on Nest's GitHub, which talks about. I guess it's asking who is using Nest, and there's a lot of companies there too that are making known that they use it. So it does have good adoption. Slides for this, you can find them at this link here, bit.ly/nestjs-angular. And a couple things that I'll announce just before I wrap up. I've just started this new kind of project called speak.dev. This is with my friend Ado. He and I speak at a lot of conferences, and it's always a bit painful when you want to find new conferences to apply to and sort of manage your CFPs, make sure you don't double book yourself and that sort of thing. So we're building this platform that's basically catered towards speakers to be able to find and manage conferences and manage their applications to conferences. So that's at speak.dev. You can jump on the mailing list if you're interested in that. We're live streaming the whole thing. We're building the whole thing live. And we'd love to get feedback as we go. Speak.dev on Twitter is where you can find us. What else? If you're interested in GraphQL, I've got this kind of fun intro sort of tutorial at trygql.com. It's fun, you just go through maybe 10 lessons and you learn GraphQL from the ground up. I've been told it's a fun time. And I've also got this kind of set of videos, Graph Collective. If you go to graphcollective.io, it's a series of like case studies from GraphQL experts, those that have put GraphQL into production. So if you or your organization is thinking about it, it can be a good resource for you to try to make some determinations as to whether it's for you. So that's it. Once again, I'm Ryan at Ryan Chenkie on Twitter, and happy to answer any questions once we wrap up towards the end. So thank you very much.
I think we actually might just do questions right now so that we keep the context the same. I don't see any in the chat. Does anybody want to ask any questions before we move on to Kara?
There's a request to put the link to the slides. I'll surely put that. Let me just grab it.
Okay, well then, Kara, I guess you are up next.
Okay. Let me make sure I actually somehow collapsed the window. I can't tell if you guys can see me or not.
I can see, yep, I can see you.
Okay, excellent. So let me share my screen. Let me know when you guys can see everything.
Yep, I can see it all and I can hear you.
Okay, excellent. Oh, I'm listening. Is that? Hello?
Hello? You're not echoing that we can hear,
Okay.
but if the echo is gonna drive you crazy, you're welcome to like sign out and come back in.
I think maybe someone has their sound up too high. But okay, seems better now. Okay, cool. Sorry, everything's good. All right, so today I'm going to talk about how Angular dependency injection works. Oh, there we go. So We're going to start with an overview of Angular dependency injection in general. So how you use it in general, how it's supposed to work, just in case maybe you're not familiar or you haven't used it in a while. And once we've reviewed that, we're going to jump into a deep dive of how the directive injector algorithm actually works. So this should give us a chance to go into kind of more low-level code concepts. Hopefully that will be interesting to people. Okay, so let's start with the overview. So what is dependency injection? Dependency injection is a design pattern where dependencies are retrieved for you by something else. So in this case, the Angular framework. So if you need a component instance or you need a service of something, you don't have to go look for the right instance of it. Angular will just give you the right one. And in practice, it looks something like this. If you want to inject an instance of something, you just add its type to the constructor of the class that needs it. And whenever the framework creates that class, it will make that service or component available to you. So where does Angular get all of these services or components that you're requesting? Well, there's a few different ways that you can provide values to the dependency injection system. One way is you can add the type to the providers list in an ng module decorator like this. You could also add it as a provider to an @directive or @component decorator. And depending on where you add a provider, you're actually going to be using a different dependency injection system. So there's two different dependency injection systems in Angular. There's the module injector and there's the directive injector. So if you add it to the ng module, you end up with a module injection system. And if you add it to a directive or component, you end up with a directive injector system. And so both of these ways are kind of ways that you can explicitly provide something, but there are also things that you can request through DI that don't have to be provided specifically. So an example of that is if, say, the author of my service added a provided in property to their injectable decorator. In this case, you wouldn't have to provide it because the framework, because if it's not provided, the framework will just pretend as if my service had been provided in whatever module you specify. So in this case, the framework pretends that my service was provided in the root module. So this is something that's completely implicit. Another way, or another set of things that are available in DI are component and directive instances. So these are things, once again, that you don't have to explicitly provide. If you add a directive or component to a template, then they're just available through DI. So as you can see, there's a few different ways that you can make things available through DI, whether it's explicit or implicit. But the main thing to take away from this is that there are two different types of injection. There's module injection and directive injection. So why do we bother to have two different systems? Well, they have different trade-offs. So it kind of depends what you want to do. So the module injection system is the simplest use case, right? You get exactly one injector for all of your eager modules. And all of the providers that you get are singletons. So for every token, you have exactly one value. And it's completely flat. So if you have a module that's deeply nested in the module tree, it's at the very bottom, and you provide something there, that provider will also be available in the very top root module, and vice versa. And this is not exactly how it works with lazy modules, but for all intents and purposes, the module injector is a great thing to use if you have something that you want to make available to your entire application, for example. And it's really simple to implement. It's just a map. So it's just a bunch of keys that are tokens and values that are the instances. So we're not really going to talk a lot about the module injector today because it's pretty straightforward. Okay, but let's say you want more fine-grained control. That's where the directive injector comes in. The directive injector is hierarchical, so you don't have to have a one-to-one mapping between tokens and instances. You can have multiple instances of the same token. So a good example of this would obviously be components, right? You could have many component instances. And instead of having just one injector, we create a new directive injector for every node that has directives. So the system just at large is a bit more complicated. And in terms of how this works, the hierarchy. So if you take this example, let's say this is the template for app component, and inside it you have, component A is the root component, and then you have component B and component C are the content children of component A. You'd end up with a DI tree like what we see on the right. App would be on the top, component A would be right underneath it since it's the root element, and then you'd see component B and component C at the bottom since they're both content children of component A. So if you wanted to inject something in component B, you'd have access to everything in component B, but you'd also have access to everything above component B in the hierarchical chain, right? Component A and also app, even though app isn't in the same template. And you'd have access to any of the providers that those components and directives have in their decorators. What you would not have access to is component C, since it's a sibling. So as you can see, it's a little bit more complicated. So for time reasons, we're going to focus on the directive injector and how that works. So let's jump into that. So if we take this, again, the same template as an example, let's start to brainstorm how we might implement the system that I just described. So the first thing that we need is a way to keep track of all of the directives and components that we've created, and also anything that those directives or components provide, right? So any related services. So one way to do that might be to create a map for each node. So each node has a map that contains all of the components, directives, and services that exist on that node. So that's a good start. We obviously need to keep track of everything. But we also need a sense of hierarchy, right? We need to know that everything in the component A map is available to the component, to the directives in component B. So we also have to build up the tree. So maybe we add something like a parent property so that we can walk up the DI hierarchy. So together with these two items, maybe we create something like an injector object that has a storage map inside it, and also a parent property that points to the parent injector. So maybe it would look something like this. So in terms of what the most naive DI algorithm might look like, so we're going to refine this over time. But let's say you want to inject something. You would start at the current injector object for whatever directive that is injecting something. You would search the storage map for the token that you want at the current injector. If you don't find it, you use the parent property to traverse up to the parent injector, search that storage map for the token requested. And you keep repeating this until you get to the root, at which time it actually falls back to the module injector. So you go through the whole directive injection system before you even start checking the module injector for providers. So this would work. This would be totally fine. You could have maps for every node. You could do this. However, something like dependency injection, which happens while views are being created, is really performance sensitive. It's in the critical path. So this is what's going to be happening when you're loading your application for the first time. So for this reason, we have to be really, really, really careful about both memory and performance. So there are improvements that we can make. So the first thing that we could improve is our, excuse me, is the number of objects that we're creating. So right now we're creating an injector object for every node that has directives. And we're also creating a storage object within each of those injectors, right? So it's a lot of overhead. If you imagine having, a huge application that has a lot of components and directives, that's a lot of objects that we're creating. And that's a problem for two reasons. So one, obviously, if you create a lot of objects, that's not great for memory. If you have something like a mobile phone, it doesn't have the capacity that, for example, your desktop computer might have. But there's also runtime performance implications, right? So if you have every object that you create, it takes time to create it. But more importantly, it adds pressure for the garbage collecting system. So the more objects you have to keep track of, the longer your garbage collection cycle takes. So if you run into one of those GC cycles, it could really make your application laggy. So anyway, all of this to say, the first thing that we should do is we should try to flatten all of our data structures, this injector object thing that we've created, to make it more memory efficient. And this is something that we actually do throughout the framework. So we have a lot of things that we have to keep track of in the framework, like elements and binding values and directives. And we could create separate objects or arrays for each of these like different types of things. But again, that would be pretty expensive because there's so many things that we need to keep track of. So in the framework, for each view, so for each component template, we create one big array that contains all the instance specific data for that view. So this array contains, your DOM elements, it contains your binding values, and you'll notice that none of these are being grouped into objects or nested arrays or anything like that by node, even though that would be convenient. We have them completely flat just to keep our memory profile really low. So for these injectors that we're going to end up putting in the same LView array, we don't want to create all these nested objects and ruin that effort. So instead of doing that, we could do something like this. So this is all the same information, but just in a different format. So instead of having injector objects, we could have each injector exist as a range of indices in this LView array. So the injector for component A is indices 10 through 12. The injector for component B is 13 to 14, and so on and so forth. So you have all the same information, but just flattened. So you look at one of these injectors. In each grouping, the first index is going to be the index of the parent injector. So we still have that tree structure. So for component B, we record 10 here so that we know, hey, its parent injector starts at index 10. And then after the parent index, we just store all of the things that we've created flat through some range. So here we have component B. So let's say that component B wanted to inject component A. So the algorithm would be pretty much the same. So we'd start at component B's injector. We'd see that, okay, the parent for component B is going to be at index 10, and we remember that. We search the injector for component B. For component A, we don't find it, obviously, because there's just one item here. So we jump to the parent injector, which we know is at index 10. And then we search the parent injector, and we find component A. So again, this will work, but you might notice that we've created a new set of problems, right? So while the data structures are super flat and efficient and beautiful, we now have this pattern where we're jumping to each injector and we're searching a flat list, right? We no longer have that constant time check that we had with the map because we have to look, iterate through every instance individually. And that could be pretty slow, right? If you have a big application with lots of services, lots of components, you end up searching a lot of lists. So one performance improvement we could make is we could only search that subsection of the array for the injector if we're reasonably sure that that token exists somewhere in that injector. Okay, but how are we going to know if something exists inside the injector without searching it? Well, the easiest solution would be to add something like a set, right? So we could just say, as we push things to storage, we mark down the types so that later we can just say, hey, is the type in this set? If it is, then we search the storage. If it's not, then we keep moving up the injector tree. But obviously, if we just added a set here, we would recreate the problem that we were trying to solve with the memory, right? We'd have a bunch of nested objects, and we don't want that. So instead of creating a bunch of sets, how about we do something like using a Bloom filter? So if you're not familiar with Bloom filters, a Bloom filter is a probabilistic data structure that tells you whether something is definitely not in a set or maybe in a set. So you can kind of think of it as a set-like data structure that is faster because it has, faster and more memory efficient because it introduces a little bit of uncertainty. And the uncertainty in our case is totally fine because in the end, what we're going to do is search the storage array or subsection of the storage. So if it's a false positive and we don't end up finding it in storage, then we can keep searching, right? So we just kind of want to sanity check before we search, search through all of the instances in an injector. So our improved DI algorithm with the Bloom filter might look something like this. So when we're going through and we're creating these components and services, assign a unique ID to each component and service. So just add an ID to the type. So like 0, 1, 2, 3, 4, 5, that kind of thing. create the instances as normal, push them into the storage subsection of the array. And then what we want to do is record the ID of the things that we've created in the Bloom filter. So if component 0 is we push to storage, we record ID 0. When the token is requested by something else, first we hash the type to its ID, which remember we stored it on the type, and then we check the Bloom filter on the current injector to see if we recorded that ID. If we did, we search the storage and incur the potentially expensive cost of searching through all those items. And if not, we traverse the parent injector and check that Bloom filter and repeat. So in this case, we know we can avoid searching the storage if we know that the item is definitely not in the set. So as an example for how this might work, let's pretend again that component B is trying to inject component A. And for the time being, I'm going to be a little hand-wavy about how the Bloom filter works, just so you can get a sense of the general algorithm, and then we'll come back and explain the Bloom filter a little bit more. Okay, so let's say we're going through this template. We're creating component A right now, and we do directive matching. We see that the component A directive matches, and also that component A provides some service A. So we assign an ID to component A, 0, and we assign an ID to service A as 1. We create component A and we create service A. We push them into our data structure so that we have our first injector here in the L view with the parent index, which we're just going to say -1 because because component A doesn't have a parent. And then we're pushing the instances in our storage, component A and service A. And then we want to record that, hey, we have these 2 items here in this injector. We have component A and we have service A, so we record their IDs 0 and 1. And then we go along to component B, we create the element, we do directive matching, we find that component B exists here, we assign it an ID, this time it's 2. But when we try to create component B, we realize, oh, right, component B is injecting component A, and we can't create it until we have an instance of component A to give to component B. So how do we find component A's instance? Well, first we take its type. We look at its ID, which we set as 0. And then we check the Bloom filter on this injector to see if 0 had been written down. And again, we haven't written anything down, so it doesn't exist here. So then we go up to its parent. We see, hey, did we note down that ID 0 is here? Yes, we did. So we search the storage array here, find component A and return it. Then we can create component B and push the injector once again into our L view. And then record that 2 exists here on this injector. And then we'll continue this on with other components that we find in the template. Okay, so let's go back and explain, what do I mean when I say that we're recording it somewhere, right? What does it actually mean to record something in a Bloom filter? So our Bloom filters are just numbers, which is great because they're very memory efficient. And they're numbers that are, I'm displaying them here in binary format, so you can kind of imagine them a little bit better. But if you're doing bit manipulation in JavaScript, what you get are 32 bits to work with. So you can think of each number in each injector as like a bucket that has 32 slots. So 0 to 31. And each of these slots represents a component or directive or service that may or may not be here in this injector. So for instance, if component with the ID 0 exists, you would flip this bit to 1. If a component ID 1 exists here, you flip this bit to 1, and so on and so forth, so that each bit represents a component type. And mathematically, this is really easy to do because you just take 1 and you left shift it by whatever the ID is. So 1 shifted by 0 places is 1 because you haven't shifted it anywhere. 1 shifted by 1 place is of course 2, which you can, so binary 2 is 1, 0, and so on and so forth. So if we go back to our, our example, I'll show you how this works, in line. So we start again at component A, we assign the IDs like we did before, but now we're going to create our first Bloom filter. So we want to record that component A and service A both exist here on this injector. So we take the ID for component A, which is 0, and we shift 1 by 0 and get 1. And then we take the ID for service A, which is 1, shift 1 by 1, and then we end up flipping the bits for the 1's place and the 2's place. So we get, 0, 1, 1. So that's our first bloom filter. So then we create the instances the way we did before, but now we're also pushing the bloom filter into the LView as our second index in the grouping. We do the same thing with component B. We create the ID once again. This has an ID of 2. So in its bloom filter, we want to record that, or we want to flip the bit that's 2 spaces to the left of 1, right? So now we get 4. So when we're creating component B and we're looking for component A, first we're going to check this injector and see, okay, this bloom filter, we flipped the bit for 4, right? So we have 0B100. And what we're looking for is component A's ID, which is 1 shifted by 0 or 1. So do those bits match? Is there, is the 1 bit flipped in our bloom filter? No, it's not. So we know that it's not going to be inside the storage for this injector. So we move to the parent injector, which is 011, which you can kind of see below here, which we pushed earlier. And now we do the same thing. So we check 011, which is the parent bloom filter, against the ID that we're looking for, which is 1. So this bit on the far right. And we see that, hey, both of them do have a 1 in the 1's place. So we know that it does exist in this injector. And then we return it and keep going. So that's great. So that makes it a lot faster. There's one more. Okay, we're not doing well on time, so I guess I'll do this really quickly. There's one more thing that we could do to make it faster. So right now we're checking the bloom filter on each level of the tree individually. It would be great if we wouldn't traverse up the tree at all if we know that the token isn't present. So like a good example of that is if you had like an optional provider, you don't want to search the entire large injector tree if if something's optional and it hasn't been provided, right? Or if you have something that's a module provider, you don't want to search the whole directive injection tree if it's not anywhere in there. So what we can do with bloom filters, it makes it really easy, is we can create something called a cumulative bloom filter. And all this is basically, as we're going down the directive injector tree, we're ORing the previous bloom filter with all the bloom filters before it, so that we create a number that has the bits flipped for not only your own bloom filter, but also the bloom filters above you. So the cumulative bloom filter for component B, for example, would be the bloom filter for component A, which flips the bits for 1 and 2, but also the bits for 4 for its own injector. So functionally what this means is before you even go up to the parent injector, you can check the cumulative bloom filter and see if any of the ancestors in the directive injector tree have that component or that service. So you don't even bother checking the tree at all if you know that the flag wasn't flipped. Okay, and the last thing I want to mention is, why is there uncertainty? So you might have noticed that there's only 32 slots. So what happens if your application has more than 32 components or services, which is pretty common? This is where the probabilistic part comes in. So we modulo the ID with the bloom size. So component or service ID 33 will share the slot with ID 1. So if you have ID 33 or ID 1, they're going to flip the bit for the same slot. So you can't be sure whether what you have there is 33 or 1. And you can kind of play with this by adjusting the size of the bloom filter to reduce these collisions. The more memory that you use, the more buckets that you have, the fewer collisions that you'll have, but obviously the bigger your memory footprint. Obviously, we can't add more bits to JavaScript numbers. They have the number of bits that they have. But what you can do is you can add more numbers. So you could do something like this, where you have more than one number per injector. So each injector could, for example, have 4 numbers, and each number could have like a different range of IDs represented like this. So anyway, so hopefully that's went through that really quickly. But it's kind of interesting because it's it's really uncommon to see data structures like this in front end. I think it's kind of interesting. So hopefully you guys did too. So that's it. Thanks.
Thank you, Kara. Does anybody have any questions for Kara? Speak now or forever hold your peace. I guess not. Okay, well then you are all set. Oh wait, isn't it possible to use the 32-bit structure for longer numbers?
I'm not sure what you mean by that. Can you clarify a little bit? Like use it how?
You're welcome to unmute yourself if it's easier to just talk.
Yeah, that probably would be easier. Oh, the lights just went out in my room.
You haven't been moving enough.
Oh. Oh, I'm sorry that was difficult to follow. Yeah, I can post a link. I don't have the slides right now linked anywhere, but I can send it to Eva to tweet out, I guess.
Yes,
Okay.
I'm happy to tweet it out if you send it to me. Any follow-up to that first question? Okay, well then thank you both very much, and I really appreciate you guys coming on and talking.